Welcome to EDU World Space.
Hello and welcome to Chapter 1, Problem number 26, in Physics for Scientists and Engineers with Modern Physics. So in this problem, we're asked to create a scale model given the diameter of the atom of a hydrogen atom and the diameter of the hydrogen's nucleus. Also, we're given the diameter of the scale for the atom. So here are all the values that we have, and we also are going to need to convert feet into millimeters at the end, but we'll get to that when we get there. So here's our foot conversion. So to start things off, we're really just going to do a proportion constant to get the diameter of our scale nucleus. That's why I have SA, scale atom. So we're going to have dA over dN is dSA over dsN. We're going to cross multiply and then isolate for the diameter of the scale nucleus. And then we're going to plug our values in. And we'll end up getting about 6.79 times 10 to the negative 3 feet. It might seem a little bit short, a little small, considering we were working with 300 in the beginning. But if you look at it, it's actually pretty close because the diameter of the nucleus is 5 degrees of magnitude less than that of the atom. So it's actually pretty accurate. So converting that into millimeters, we're going to use our conversion factor and then multiply it by 1,000 millimeters at the end here. So we'll get about 2.07 millimeters. Now that's pretty small compared to 300 feet, but that's what you should expect from the diameter of an atom compared to the diameter of a nucleus. Up next, it asks us to calculate the volume and compare those, the ratio of the volumes. So we model atoms and nuclei as spheres, and so the volume of a sphere is going to be 4/3 times pi times that radius cubed. We're not given the radius explicitly, but we are given the diameter, so it's just a matter of dividing that number that we had up top here. I'll go back up to it for a second. These values up here, we have to divide these by 2. That's pretty much it. So in order to do that, let's go back to our calculation. We're going to find the volume of the atom first, which will be 4/3 times pi times that radius, which is 1/2 times the given number, and then cubed. And so we're going to get about 6.24 times 10 to the negative 31 cubic meters here. And for the next one, same process, except a different value. And we're going to get 7.24 times 10 to the negative 45 cubic meters. And yes, they're both very small. So we put the ratios on them together. We divide the atom by the volume of the nucleus. We'll get about 6.81 times 10 to the 13.